Hello everyone, welcome back. In today's video, we're going to understand one of the most important passive electronic components, the capacitor. By the end of this video, you'll know what a capacitor is, how it works, how it charges and discharges, its types, and where it is used in real electronic circuits. A capacitor is a passive electronic component that stores electrical charge and electrical energy in the form of an electric field. It is represented by this symbol in electronic circuits. One important property of a capacitor is that after it is fully charged, it blocks DC current, but it allows AC signals to pass because AC voltage continuously changes with time. Let's see how a capacitor is constructed. A capacitor consists of two conductive metal plates separated by an insulating material called the dielectric. The dielectric can be ceramic, paper, plastic film, mica, or an oxide layer depending on the capacitor type. Since the dielectric is an insulator, electrons cannot move directly from one plate to the other. Instead, opposite charges accumulate on the plates, creating an electric field. The electrical energy is actually stored in this electric field. Now let's understand the charging process. When a capacitor is connected to a battery, electrons from the battery accumulate on one plate, making it negatively charged. At the same time, electrons leave the opposite plate, making it positively charged. As charge builds up, the voltage across the capacitor gradually increases. Eventually, the capacitor voltage becomes equal to the battery voltage, and the charging current becomes almost zero. At this point, the capacitor
now let's
behaves
understand
like an
how a
open circuit for
capacitor
DC.
charges.
A simple way
Initially,
to understand
the
this
switch
is
is
by
open,
using the water
so no
tank
current
analogy.
flows through the.
Imagine a water tank being filled with water. The water represents electric charge, while the water pressure represents voltage. As the tank fills up, the pressure increases. Once the tank is full, no more water can enter. Similarly, once a capacitor is fully charged, current stops flowing in a DC circuit. When the battery is removed and a load, such as an LED, is connected, the capacitor begins to discharge. The stored electrical energy flows through the external circuit, lighting the LED. As the stored charge decreases, the capacitor voltage gradually falls until it becomes completely discharged. The amount of charge that a capacitor can store is called capacitance, represented by the letter C. It is mathematically defined as capacitance equals charge divided by voltage, or C equals Q by V. The SI unit of capacitance is the farad. In practical electronics, we usually work with microfarads, nanofarads, and picofarads, because 1 farad is a very large unit. There are several types of capacitors. Ceramic capacitors are commonly used in high-frequency circuits and digital electronics. Electrolytic capacitors provide high capacitance values and are widely used in power supplies. Film capacitors offer excellent stability and precision. Tantalum capacitors provide high capacitance in a compact size, while variable capacitors are used for tuning circuits, such as radios. Capacitors are used in almost every electronic device. They smooth voltage in power supplies, remove electrical noise in smartphones and computers, store energy in camera flashes, help start electric motors and fans, create timing circuits, and filter unwanted signals in communication systems. So, to summarize, a capacitor stores electrical energy in an electric field between two metal plates. It charges when connected to a voltage source, discharges when connected to a load, blocks DC after charging, allows AC to pass, and plays a vital role in almost every electronic circuit. Thank you for watching. If you found this explanation helpful, please like, subscribe, and share this video.